Alrighty, so we're going to talk about completing the square and everyone put the stuff out of their hands, laptops down. It's a tricky concept, doesn't come up a lot, but it's important that we know it because it is very useful for solving certain quadratics we can't solve without it, and it's very useful for transforming our quadratics into turning point form. Why do we need to know turning point form? Makes it easy to identify translations, makes it easy to identify where a turning point is, makes it easy to sketch. Cool? Can we factorise this? No, I can't think of any factors that work for that. Okay. Now, to deal with this, we use this completing the square method. And that's where if we look at our function, what's our b value here? -5. Okay. So what we're doing is we're adding a b on 2 squared. We add something to the equation, what else have we got to do? We've got to subtract the same value. And the reason we're doing that is because we want to get to a point where we get this bracket here. We get that because if we've got bx plus b on 2, what we're going to have is essentially what's b on 2 squared. If we expand that bracket, we're going to get back to this. I want you to practice, I don't want you to see, I want you in your books to expand this bracket. And just somewhere off to the side, expand that bracket like that, and check that we get this big bracket up here. I'll give you 10 more seconds. Does it check out? Is that what we get? Let's have a look. I get x squared plus b on 2x plus b on 2x plus b on 2 squared. So do you all get? And then we collect like terms, we get x squared plus bx. So you get on 2 because there's 2 of them. Cool? Doesn't make a lot of sense when it's B's and C's, so let's use some numbers. Okay. So the first thing I want to do when I'm solving this, 0 equals, I'll rewrite my line. What's my B value again? -5. So the first thing I need to do is add the special value. So I'm going to have x squared, that stays exactly the same. I'm going to have plus 7. I want you to add in what I need to put in there. Now hopefully you put in plus 5 on 2 squared minus 5 on 2 squared. Hopefully you did that. Now I'm just going to put imaginary brackets. I don't need these, but I'm just going to put imaginary brackets. Why do you think I'm putting those in? So I can separate it, so I can see that I'm clearly dealing with 2 separate parts of this problem. So I'll do this part in purple. I've now got x minus 5 on 2 squared. That's exactly that process, but in reverse. Why is it minus not plus this time, bud? I started with a -5. But do I still get plus 5 on 2 when I do that?
Yeah.
What's -5 on 2 times -5 on 2? Positive 5 on 2 squared. Cool? So if you've got a negative sign here, you need a negative sign there. If you've got a positive sign, then you need a positive sign. Cool? So that accounts for this. What do I need to make sure I've now got in there? What's minus 5 on 2 squared? What's that? How can I write that? 5 on 2 squared is? 25 over 4. I want to represent 7 as a fraction over 4. How do I do that? Times by 4. So what's 7 times 4? 28 over 4. I leave the first part exactly as it is. And then I just add up the back, which leaves me with 3 on 4. So what's the turning point of that function? The turning point, I want you to fill in these brackets. The turning point. Now I didn't solve this yet, sorry. What do I have to do to solve it? I have to find out what x is, correct? So I've completed the square, now I need to solve it. What should I do? Not substitute, starts with R. Rearrange. What should I attack first, Cameron? 3 over 4, how do I get rid of that? Minus 3 and 4 equals x minus 5 on 2 squared. How do I attack that? How do I get rid of, what do I attack now, Jake?
Would you take away 28 over 4?
I've already
3 over 4, I mean?
I've already done the take 3 over 4. So my next step, square root.
Square root times 4.
Yeah, and that leaves me with x minus 5 on 2. Anyone in the room tell me what's going on? The answer's a bit like my social skills. Imaginary? Not real? Why is it not real? Square root of a negative number. What's that tell me? What are the situations with a quadratic? With what is the 0? What's that telling me? When I'm asking to solve, I'm finding out what on the graph. The y-intercepts. The x-intercepts, correct? So what's that telling me? There's no x-intercepts. Does that make sense? Can we have a quadratic with no x-intercepts? One that's got a positive a value and starts above 0. That sounds like a quadratic which would have no x-intercepts, doesn't it? If I was to draw a rough sketch of this, it would look something like this, correct? And that point there is 5 on 2, 3 on 4, isn't it? So it makes sense. Cool. Now, do I expect that you understand that? I've written it on the board one time, so now we understand it. All good? Is that how it works?
Where did the 28 over 4 come from?
That's the 7 being represented as a fraction over 4. So because this base is 4, I need to make that base 4 just to make adding it a bit easier. So I multiply that by 4 and divide by 4. Cool. Happy with that? I'll give you one more example with those and then we'll get back to our work. Because it is challenging. So I'll get you to solve x squared minus 4x minus 6. Off we go. At least I've given you a nice number, not like last time. 5 on 2. Yeah. 2 on 2. 4 on 2